Okay, this is fun applications with rational equations. So here's your problem solving steps. You read the problem, assign a variable to the unknown, put in information into the table, write an equation, solve it, see if it's reasonable, and then write your answer in the context of the problem. So here we go. Like, what? I'll show you. An experienced bricklayer constructs a small wall in 3 hours. The apprentice completes the job in 6 hours. How long will it take if they work together? So we have the guy, the experienced guy, and we have the apprentice. Good? Now, it says hours to complete the total job, part of the job completed in 1 hour. So the experienced guy completes the job in 3 hours, and the apprentice, if he's working alone, completes it in 6. So now I have this third column here that says part of the job completed in 1 hour. That's 1/3 of the job. So if it takes this guy or woman 3 hours to do the entire job, then that person will complete 1/3 of the job in the first hour. The apprentice will complete 1/6 of the job in the first hour. Now I'm going to construct another table, okay? And I am going to say that the rate times the time worked is equal to the total work done, okay? So we're going to create another table here. And let's talk about the experienced person and the apprentice person. The rate at which the experienced person works is 1/3. Okay, that's the part of the job completed in an hour. So he or she completes 1/3 of the job per hour. Per hour, it's a rate. The apprentice is 1/6. Now, time, they're going to be working together on this job, right? Good. So they're each going to work some X amount of hours. Good. The total work done by the experienced person is 1/3 X, because he works at a rate of 1/3 times the time, and that'll be the total amount of work she or he does. The apprentice, it's 1/6 X. Now we can set up the equation. Are you ready? Here it goes. The work done by the experienced plus the work done by the apprentice is going to equal 1 job. Cool. 1 total job. Well done. Good. Now let's think about what our answer could be. If the experienced person does it in 3 hours, okay, when he or she is joined by another person, it should take less than 3 hours to do the job, because if it takes more, forget it. The experienced person just might as well do it themselves. You know what I'm saying? So let's do our work done by experience is 1/3 X. Work done by the apprentice is 1/6 X, and it's equal to 1 job well done. We know how to solve these. I'm going to multiply everything through by a common denominator, which is 6. So I'm left with 2x plus x is equal to 6. 3x equals 6. X is equal to 2 hours together. So I'm going to write that, the sentence that completes it. And this 2 makes sense because it's less time than the experienced person is. So cool. So the job will take 2 hours to complete if they work together. Yay! Now let's do a distance, rate, time application. A pilot can travel 400 miles with the wind. I'm going to stop there. So we're going to do with the wind, and he or she can travel 400 miles in the same amount of time as 300 miles against the wind. So against the wind, I'll start singing the song, 300 miles. Good? If the wind speed is 20 miles an hour, what is the pilot's speed in still air? So rate, we're going to look at rate. So let's call it, now with the wind's going to push him along, so it's his speed in still air plus the speed of the wind. It's going to push him. So x is speed in still air. Good? Now, against the wind would be x minus 20 because the pilot's flying at a certain rate and the wind is going against the plane, so it's slowing it down. Now, the question is, how do I get some kind of equation out of this? Would you agree with me that the time with the wind is equal to the time against? How do I know that? In the same amount of time. So how do I figure out the time? Well, we know that rate times time equals distance, but time is equal to distance divided by rate, isn't it? So I can take 400 and divide it by x plus 20 and get the amount of time the pilot is going with the wind. The same way, against the wind, it's 300 divided by x minus 20. So cool. So I can write these I love it because it's a proportion, and when you have a proportion you can cross multiply. So it's going to be 400 times x minus 20 is equal to 300 times x plus 20. Good? We'll distribute, and we'll get 300x plus 6 with 3 zeros. That would be 6,000. 400x minus 8 with 3 zeros, or 8,000. Bringing everything over, subtract 300x, add 800,000 actually. And I'll get 100x is equal to 14,000. If I divide by 100, x is equal to 140. Now, does that make sense that a plane can travel 140 miles an hour? Yes, especially a small plane can travel that. Okay, so how do I write my answer? The pilot's speed in still air is 140. Let's make it look cuter. 140 miles per hour. Perfect? Nice. Let's do all these problems. Okay, this is an application using numbers. 5 divided by the difference of a number and 12 equals the quotient of 10 and the sum of the number and 9. Find the number. Okay, here we go. Let's do it in blue. All right. 5 divided by the difference of a number and 12 equals the quotient is another division way to say it, the quotient of 10 and the sum of a number and 9. Good? the quotient of 10, and the sum of the number and 9. Find the number. All right, I kind of got a little ahead of myself. I'm going to let n equal the number. I love this problem because it's another cross multiplication problem because we have a proportion. Nice. Distribute 5n plus 45 equals 10n. Take away 120. So I'm going to bring the 5n over to the other side. And I'm going to add 120 to both sides. So get 5n is equal to 165. I'll divide everything through by 5. So I'll get 33 is equal to n. So the number is good. Let's check it. 5 over 33 take away 12. Is that the same as 10 over 33 plus 9? 10 over 42. Is that the same as 5 over 21? You betcha, because if I divide both of these by 2, I am all set. Don't you ever let fractions scare you. Just take your time with it. You'll be awesome. Next. All right, this is a work application. Okay, for this problem, I'm going to kind of divide this up a little bit differently. And then I'll put in a couple labels. Okay, so one pump fills a tank in 9 hours. So pump 1. Hours to complete the total job, 9. Part of the job completed in 1 hour, 1/9. And that's your rate for pump number 1. A second pump, pump number 2, fills the same tank in 6 hours. So hours to complete the job. Part of the job completed in an hour is 1/6. Now pump number 3 is going on. It says when a third pump is added, all 3 are used to fill the tank. It only takes 3 hours. How long does it take for the third pump to fill the tank by itself? So hours to complete total job, we don't know. But the rate would be 1 over x. Perfect? Good. So now let's see. Let's do now the rate, time, together. Good? Now, the work done by pump 1 plus the work done by pump 2 plus the work done by pump 3 is equal to 1 job. Okay, so let's do pump 1 here. What's the rate? 1/9, right? What's the time together? 3. Very good. Let me just erase this 1/9 here. Looks yucky. 1/9. So when I multiply those together, 3 times a 9th will be 1/3, right? Perfect. Now let's do pump 2. Yeah, let's. The rate for pump 2 is 1/6. The time together is 3. So when I multiply those, 1/6 times 3 over 1, I get 3 over 6, which is 1/2. Good. Now let's do pump 3. Its rate is 1 over x. Time together is 3. So when I multiply them, good, I will get 3 over x, and that's equal to 1 what? 1 job of filling a tank. Now we're like, yeah, I get this. I'm going to multiply everything through by common denominator, which is 6x. So 6x is equal to, the x's will cancel. We get 18 here. It should be a plus. 3x. And then when I multiply 6x times a third, I'm just going to get 2x. So I'll get 5x plus 18 equals 6x. Take the 5x over to the other side. X is equal to 18. What? 18 hours. Okay, is that viable? Sure. It can be longer time than 9 and 6. Good? So now let's write it in a sentence, and we say the third pump takes 18 hours to fill the tank, working alone. Cool? All right, now go for it. And try not to panic. Ask lots of questions on these. You can do this. You got this. All right? Do that math.